Hello, I'm Bradley Hauer from the University of Alberta in Canada. Today, I will be presenting our research on behalf of myself and my co-workers listed here on this slide on translation-based lexicalization generation and lexical gap detection with an application to kinship terms. Let's begin by looking at an example from the popular translation service, Google Translate. At the bottom of the slide, you can see here a perfectly reasonable Chinese sentence involving words, which I've underlined, referring to the elder son of a father's brother and the elder daughter of a father's brother. These are terms which are lexical gaps in English. That is, there is no single English word that can express either one of these concepts in English. And we see that as a result of that, Google Translate makes an error. It translates both as the more general term or hypernym, cousin. And as a result, this perfectly reasonable Chinese sentence ends up with the nonsensical translation, I have a cousin, but no cousin. Other translation services that we tried, such as DeepL, make similar errors. ChatGPT, another popular online service used for general chat interactions rather than just translation, can make similar errors. In this example that you see on the screen now, we provide ChatGPT with some context, some examples of specific kinship terms in Chinese, father's younger brother and mother's brother, and ask for a word that means elder brother. And ChatGPT tells us that the English word meaning elder brother is brother, which of course is not correct. That's a more general term, a hypernym. This, again, is a lexical gap in English. There's no single word in English that means elder brother, and so this system makes mistakes. So we can see that even fairly sophisticated systems for translation or chat can make mistakes when encountering lexical gaps, such as elder brother. And that's what motivates the work that I'm presenting here today. Here's a brief outline of our presentation. We're going to start by talking about what the problems are. How do we identify concept lexicalizations and lexical gaps efficiently and automatically? We'll then go into our basic idea, starting with the theoretical foundations that are based on the hypernym and hyponym relations between concepts and the exclusive disjunction relation that exists between sibling concepts, and how that relates to the lexicalization patterns that we observe. We then introduce a novel translation-based method that generates and filters candidate lexicalizations. Finally, we will present our results, where an empirical evaluation demonstrates that our approach yields higher accuracy than BabelNet and ChatGPT. So let's get a bit more in depth with the notion of concepts. A concept is a discrete word meaning. So something that we could relate to a particular sense, something that we could map to a specific entry in some kind of lexical database or ontology or dictionary definition. And we focus in particular on kinship concepts because they have clear definitions and a hierarchical structure. They are well studied, and there is a good, recently published gold standard data set available from Kishig et al. 2022 that we use in our experiment. So you can see from the example here, we have this hierarchical relationship from the top-level concept sibling, which then breaks down into more specific concepts such as elder sibling, and then even further into, for example, elder male sibling. So it's that systematic hierarchy of concepts that we're going to be looking at today. So what we want ultimately is to be able to generate a table like what you can see on this slide here. We want to be able to identify lexicalizations, single words which can express or lexicalize a concept. And we also want to be able to identify when there is a lexical gap. As you saw at the beginning of this presentation, these lexical gaps can have a serious impact on the performance of large language models. And so it would be very helpful if we could automatically identify where and when those gaps exist. So if we find that a concept has no lexicalization in a given language, we want to be able to represent that explicitly, as is the case in this table here. So ultimately, our goal is to be able to build tables like this automatically. So let's define our tasks a bit more formally. We have two tasks, lexicalization generation, or LexGen, and lexical gap detection, or LexGap. In both cases, the input specification is the same. We are given a concept, such as, for example, elder male sibling, and a language, for example, Chinese. And we must decide whether or not the language has a word for that concept. So for LexGen, we want to either output the word or output a special gap token indicating that there is no such word. Lexical gap detection is a binary classification problem where the correct output is true if there is no lexicalization for concept S in language L and false otherwise. So this leads to a rather intuitive relationship between LexGen and LexGap, where LexGen returns a gap token if and only if LexGap returns true for the same input. Now let's take a look at the theoretical basis for our method, how we're going to leverage these relations between concepts in order to develop and support our method. First, we postulate that if a concept is an exclusive disjunction of its hyponym concepts, that is, if every P is either a C1 or a C2, then typically we would not see P and C1 expressed with the same word, since that can lead to an apparent contradiction. You can have cases where something is a W, but not a W. And in what we're putting forward, what we're proposing here, is that that is uncommon in practice. Looking at the relationship between sibling concepts, we make a similar proposition, which is that if you have two concepts which are an exclusive disjunction, every P is a C1 or a C2, then expressing C1 and C2 with the same word can result in a colloquial contradiction. Again, we could have something be a W but not a W, which is typically not something that is observed. It is a rare phenomenon in language, and so we leverage that in our method. And putting this all together with a corollary, we find that if we have a triple with a parent and two children that are an exclusive disjunction, then in general, we would expect all three of them, if they are lexicalized, to have distinct lexicalizations. So now, with that theoretical backbone established, we can present our method. We begin by generating a candidate lexicalization by translating a seed word that is known to unambiguously represent the concept. This gives us a candidate. We then filter the candidate to make sure that it actually is a lexicalization and not, for example, a hypernym translation, as we saw in our first example. We begin by filtering out multi-words, such as male cousin, since in our development experiments, those were almost always phrase-based translations attempting to cope with a lexical gap rather than actual correct translations. We then apply proposition 2, showing that if two sibling nodes have the same lexicalization, we assume that that is indicative of a lexical gap. We then try back translation. So we check whether we can back translate the candidate to recover the original seed word. If that doesn't work, we assume the translation is bad and return a gap token, or true in the case of LexGap task. And finally, we apply our proposition 1. So we look at if W was generated for a child and a parent, so two nodes that are in a relationship, and we find that the another child of the parent node, or a sibling of the node in question, has already been tagged as a gap, then we return gap. And that is exploiting the observation that languages typically have consistent lexicalization patterns. If the candidate makes it past all of these filters, we return W for the LexGen task, we return the candidate, or false for LexGap. For our experimental setup, we use the data from Kishig et al. 2022. We use Google Translate for translation. We evaluate LexGen using accuracy and F1 retrieval metrics for LexGap. We compare to a simple all gaps baseline, the BabelNet multilingual lexical resource, and ChatGPT with the GPT 3.5 Turbo large language model. Also on the slide, you can see the languages that we used for development, English, Mandarin, and Persian, as well as the variety of languages that we used to test our model. Finally, we come to our results, where you can see that on English, Mandarin, and averaged across all of our test languages, we find that our method, which is the blue bar on the right of each graph, outperforms or rivals the performance of all other comparison methods across all languages and both tasks. So we find that our novel method is at least as good as, and very often better than, what has been done with prior work. So in conclusion, we present a novel translate and filter method for generating lexicalizations and detecting lexical gaps. Our method is grounded in linguistic theory with clear definitions and propositions, and leverages translation and hypernym-hyponym relations. In the future, we plan to generalize our work beyond kinship to other domains. Our code and data is available at the GitHub link on this screen. Thank you.